Problem number 9. Bill is leaning on a box of mass 30 kilograms, exerting a force 35 degrees below the horizontal. If the coefficient of static friction of the box on the ground is mu s equal 0.4, what is the minimum force needed for the box to slide? Solution for problem number 9. Suppose Bill exerts force F, then the maximum friction force equal mu static multiplied by normal force. But normal force equal force F multiplied by sine theta plus mg. So it means that applied horizontal force Fx equal F multiplied by cosine theta, and it must exceed force of friction. It means that we have this inequality from which we can find a minimum force F. That will be this expression, which is 203 newtons. That's answer C, and that was a solution for problem number 9. Задача номер 10. Problem number 10. Two springs with a spring constant 2 Newton per centimeter and 4 Newton per centimeter are connected in parallel. They are both connected in series to a spring of a constant 3 newtons per centimeter as shown. What force must be exerted at the end to extend the system by 1 centimeter from its relaxed length? Solution for problem number 10. Let's mark all spring constants by these meanings. Now we can use a regular formula for calculations of parallel and series connection for springs. For spring 1 and spring 2 in parallel, we have formula K4 equal K1 plus K2, which is 6 newtons per centimeter. And for series connection of spring K3 and K4 we have equivalent constant for whole construction is 2 newtons per centimeter. It means that we have to exert force F equal K delta X, which is 2 newtons. That's answer B, and that was solution for problem number 10. Problem number 11. Water with a total mass big M is poured into a cup of a cross-sectional area A. A block of mass small m, whose density is half that of water, is tied to a thin string. The string is attached to the bottom of the cup, and the block floats in the water as shown. The atmospheric pressure is P atmosphere. What is the total pressure force that the water exerts on the bottom of the cup? Solution for problem number 11. Consider force balance on the system of the block and water. The atmospheric pressure applies a downward force P atmosphere multiplied by cross-sectional area A, and the gravity applies a downward force big M plus small m multiplied by G. Now the buoyant force on the block is 2 mg, because water is twice as dense, which means the string applies a downward tension force mg to keep the block in place. To balance all these forces, the base of the cup must exert upward force P atmosphere multiplied by A plus big M plus 2 small m multiplied by G. That's answer E, and that was solution for problem number 11. Problem number 12. Two identical bricks of mass m small are attached to two frictionless pulleys by a massless string. on a fixed slope of angle theta to the horizontal, as shown. Suppose that the coefficient of static friction between the lower block and the slope is μ, and all other surfaces are frictionless. What is the minimum value of μ so that the blocks can stay static? Solution for problem number 12. Let the tension in the string that wraps around both pulleys be T. Applying force balance to the upper block, we must have T equal mg sine theta. The pulley applies a force 2T to the lower block, so applying force balance gives us 2T equal mg sine theta plus force of friction. When the friction is just barely sufficient, we have F friction equal μ multiplied by normal force, which is 2 μ mg cosine theta. Now, combining all of them, we have mg sine theta equal 2 μ mg cosine theta. It means that μ equal 1/2 tangent theta, which is answer A, and that was solution for problem number 12.